Okay, so now that we're recording, we're going to start section 6.1 today. It's on simplifying rational expression. So really, it's going to be simplifying fractions. The very first thing I'm going to start over is just simplifying fractions that we've already seen before, that we know, just basic integer over integer fractions. And then it's going to lead to just more complex simplifying. I believe, yeah, today's also multiplying and dividing. We'll get to that because really multiplying and dividing is just simplifying fractions as well. It's the easy stuff. Okay, so we're going to start. Hold on. Yeah. Reverb there. Okay, so let's actually start with something very basic. Let's start with fractions, how we really simplified them back in third or fourth grade, whenever you learn how to simplify fractions. And what we're going to do today is I'm going to simplify these like we're going to simplify them when they're expressions. So it's going to look a little different. I want you to roll with me, though. It's going to look a little different, but it'll make sense here in a minute. Okay. Let's say we had something like, and this is just going to be simplifying. So simplifying fractions, actually, is what we're going to start with. So if we had something like, let's say 4 over 14, okay? Now, hopefully you see, both those are divisible by 2. We just cancel both, or divide 2 on top and bottom and we're done. And that's great for simplifying a fraction. Now, how we're going to do that today, though, is we're actually going to factor the top and bottom completely, okay? So 4, if we factored it completely, if we put it in factored form, it's going to be 2 times 2, okay? And then 14 is 2 times 7, okay? 2 times 2 over 2 times 7. So I know you're thinking, well, this is way more complicated. Well, it's how we're going to actually work the harder ones. And so we're using a basic example to work a harder question. So look, if we've got the same factor on top of my factor means that it's being multiplied on the top and the bottom, right? A factor is just something that's being multiplied to a term. So notice we have these 2's that are similar. So let's see if we can find this different color. Oh my. Perfect. This 2 can cancel with this 2, right? And it leaves you with 2 over 7. Okay? Very straightforward. So that's how we're going to really factor. We're going to, or simplify, I should say. We're going to factor the top and factor the bottom, and then just see what cancels out. So let's do some more basic ones just for fun. Let's say we had, let's say like 35 over, let's say 5. Okay, something that cancels completely. 35 over 5. Well, 5 doesn't factor, right? But the 35 does. It can turn into what? 7 times 5 over 5. Now, because 5 is the only thing in the bottom, look, when we cancel it, it leaves a 1. There's always a times 1 down here, right? Because times 1 doesn't change anything. So that leaves us really with 7 over 1. We just don't write, we never leave a 1 in the denominator. We just write it as 7. Okay, so and we know 35 divided by 5 is just 7. Okay, this is just the simplifying way we're going to go over today once we have variables, right? Once we have terms of binomials and polynomials. Okay, so let's look at something kind of flipped. Let's say we had, let's say 7 over 56. So 7 over 56. Well, 56 factors, right? And let's see here. 56 is divisible by 2. That leaves you 28. That's divisible by 2 as well. That leaves you 14. That's divisible by 2. And it leaves you 7. So look, if we factored 56 completely, this is its factor tree. It would be 2 times 2 times 2 times 7. Okay, so I'm factoring this number complete. Now up here, it was only factors of 2, right? 2 times 2, 2 times 7, 7 times 5, only 2 factors. Well, the 56 factors completely, 2 times 2 times 2 times 7. Now, look, I'm going to pause here, and if you're like, man, I don't have any idea where you got this, we're going to do something called a factor tree. It's going to pop up in the next chapter as well because it's how I like to simplify some radicals. But a factor tree, we start with a big number, and then we just start dividing away what we know it's divisible by, if that makes sense. We know this is even, right? So I'm going to divide it by 2, and I get 28. Now, if I get a prime number, I'm going to circle it so don't forget it. 28 is divisible by 2 as well. That's 14. And then 14 is divisible by 2 as well. That's 7. Okay? And notice you get 2 times 2 times 2 times 7. 2 times 2 times 2 times 7. Look, okay? So we wind up with the factors of 56, the prime factors of 56, I should say. Okay, so now just like before, we're going to cancel out what's common on top and bottom. Now we have a 7. And again, everything goes away on top, so we have to leave a 1. So we're left with 1 over, now look, now we can multiply these out. 2 times 2 times 2. That just leaves me with 8. Okay? And that is 7 over 56, completely factored in a very long way, right? Hopefully you say, oh, 7 and 56 are both divisible by 7, 1/8, and we're done, okay? Hopefully that's how your brain thinks. You shouldn't have to go through this whole rigmarole. But today, once we get to actual polynomial simplification, we're going to go through this. We're going to factor the top and bottom and then cancel what we can cancel out, okay? Okay, so let's look at a basic example first. Let's say I had 4x squared minus, let's say 10x over, let's say 2x. Yeah, 4x squared minus 10x over 2x. So now notice we have polynomials on top and bottom now. It's not numbers. And the goal here, it'll say to simplify. I should have stated that at the top. But we're going to simplify this completely. And I'll tell you, the last step in any of these problems after this section for chapter 6 is going to be this. We're going to get to this point and we're going to have to simplify it completely. Okay? Okay, so we're going to factor the numerator and factor the denominator. So the first step, we have to factor the top and bottom. Now, before I get rocking and rolling with this, I'm going to put parentheses around anything that has addition or subtraction. If you get in the habit of that, it'll help you out a lot, and you won't wind up just dividing the 2x by the 4x squared. Okay, it's a very common mistake, and it happens all the time. But just a parentheses a lot of times just helps with that. Okay, so let's look at the numerator. We got 4x squared minus 10x, and I'm going to factor this completely. Now notice this is going to be a GCF. 4x squared and 10x have common factors, so let's factor that out first. 4 and 10, we can factor a 2 out. X squared and x, we can factor an x out, right? And we're left with, okay, the first term would be 2x. The second term would be minus, now 10 divided by 2 is 5, and we factored the x out, so 2x minus 5. All over, and now we've got a 2x still down here, right? Oh, hey, look, notice these are the same. Look, these are two factors. We got a factor of 2x on top and a factor of 2x on the bottom. So really what we're doing is we're factoring the 2, and we're also factoring the x. Now remember, that leaves us with a 1 in the bottom, but we just don't write the 1. So therefore it leaves us with 2x minus 5. It leaves us with what's in the parentheses, okay? So you're going to factor the top and the bottom. Now this denominator didn't factor because it's just a single term. Single terms don't factor per se. Now the number might factor, but the term doesn't factor like we did in the last chapter, right? So we're going to factor the top and bottom and then cancel out common factors. Okay, cancel out common factors, excuse me. Okay, so let's look at another one. Let's say we've got one very similar to this. 3y cubed over 6y to the 4th minus 3y cubed. Okay, same kind of thing. We're going to simplify everything so far. Simplifying, if I don't say it, we'll get to multiplication division here in a second, but it's not going to help us if we can't simplify. So I notice a minus sign in the denominator, so I'm going to put parentheses around it. Okay, and then again, first the numerator can't factor. It's a single term. Okay, so I'm going to factor the denominator out. So I got a 6 and a 3, so I know 3 can come out because it's divisible by both of those, right? I've got a y to the 4th and a y cubed. Well, a y cubed can come out because it's the lowest of those two variables. So let's see what's left over. In the first term, I'd have 2, right? 3 times 2 is 6. And I would need another y. Y cubed times y would give me the y to the 4th. The 3y cubed, though, that's everything here, right? Now we've got a minus sign. And remember, we have to have a placeholder. So it's going to be minus 1. You multiply it back through, you get the 3y cubed. Kind of neat. Okay? And then look, just like this one above it, we've got cancellation. The 3 cancels with this 3. The y cubed cancels with this y cubed. Now, everything's gone in the numerator, so we have to leave a 1. And then in the denominator, we're left with 2y minus 1. Now, I'm going to tell you, in the answer, they're not going to put parentheses, okay? It'll just be 1 over 2y minus 1, right? That's going to be your solution. Now, if there were multiple factors left, it would leave it in parentheses. We'll get to ones like that here in a little bit. But it's 1 over 2y minus 1, okay? Questions, comments, guys, concerns? Okay, let's go over a little trick that Dr. Martin Gay, I don't know why, but she loves this trick, okay? And I don't know if it has necessarily a name, but if you have two numbers that are being subtracted, and let's say you want to cancel them, but they don't match up, and you need the B to be first and the A to be second, you can actually factor out a negative, and it flips the A and B around the minus sign. So if you take out a negative, it actually flips the A and the B. So it becomes B minus A. And if you want to check it, if you're like, no, Mr. Shirley, I think you're lying. If you distribute the negative back through, this would be a minus B. This would be a plus A, right? So you can make the plus A the minus B. It's an order. It's a goofy order thing, okay? So let's say we've got, I'm gonna use this as an example, okay? Let's say for this example, we've got 2 minus x over x squared minus 4. Now remember, this is all simplified completely, okay? Simplify completely. Well, the numerator doesn't simplify, right? 2 minus x, there's nothing that factors out. It's not a binomial, so it's not going to simplify. So the denominator, though, is x squared minus 4. Hey, this is one of those 5.6 polynomials, that special polynomial, where we've got the difference of squares. So this winds up being 2 minus x on top. On bottom, this is actually x minus 2, x plus 2. It's the difference of squares. Okay? So now look, x minus 2 and 2 minus x. See how they're almost the same, right? 2 minus x minus 2. Man, if we could just switch this, it would be the same exact polynomial or binomial. And if it's the same binomial, then we can cancel it out, okay? So I'm going to do that. I'm going to use that trick we just went over for this numerator. If I can factor a negative out, it would become x minus 2, right? 2 minus x, factor the negative out, becomes x minus 2. And that makes it match the x minus 2 in the denominator, okay? That makes it match the x minus 2 in the denominator. Now we can cancel out this binomial because it's the exact same. Now on top, it looks like all we're left is a negative sign, but really remember it's -1, right? You can even write a -1. If you go back to that that example earlier, I think I just put the piece of paper in the trash, but it can be written as a -1. So that leaves us with actually -1 over x plus 2. -1 over x plus 2. Now, sometimes your book might move that negative to the front, so it'll look like this, negative, and then the 1 over x plus 2. There's nothing wrong with that. You can move a negative sign, top, bottom, top, middle, or bottom, as long as there's only one negative sign, okay? These are the same exact thing. Same exact thing. Okay, let's see here. Let's see here if we can get some other examples going on. Just go dig in your homework first. Okay, this is number 16. So let's say we had x squared. It's going to look similar to that. Minus 25 over 5 plus x. Okay, so same thing. Simplify completely. It says simplify each rational expression. Okay, so let's simplify this completely. So x squared minus 5, just like this polynomial up top, this is a difference of squares, so we can factor it as the x minus 5 and x plus 5. So x minus 5, x plus 5. And then in the denominator, we've got 5 plus x. Now look, order doesn't matter with addition, right? That commutative property says, look, if you've got x plus 5, it's the same thing as 5 plus x. So you can leave this for addition and just cancel these directly, okay? The subtraction is what means you have to flip it, right? 2 minus x is not the same as x minus 2, right? I mean, 5 minus 2 is not the same as 2 minus 5. We agree with that. One's 3, one's negative 3. But 5 plus 2 is the same as 2 plus 5, right? With addition, it does work. So therefore, because addition has the commutative property, the x plus 5 and the 5 plus x are the exact same. They can go away. So this leaves us with x minus 5. Okay, the whole denominator went away. And notice it's an entire binomial that's being canceled. You know, I didn't up here, same thing. It's not that we're canceling the x and the negative 2. No, this is one number, right? X minus 2 is some number out there. It's like 7, right? Where x is 9, so 9 minus 2, 7. So this entire parentheses is a number. And that's why I've got to cancel it together. You can't cancel the x and then cancel the 2. I mean, we couldn't cancel the like 5, you know, the x here and then the 5 over here. That's not going to work. It's got to be the same thing in the set of parentheses on top and bottom for it to cancel. Okay, that's one of the reasons why we make the parentheses. It's because the whole set of parentheses has to match, has to go away. Okay, great. Okay, so let's kick it up a notch. This is number 26 in your homework. We've got 3x squared minus 11x plus 10 over x squared minus 7x plus 10. Okay, so the first things first, I'm going to put parentheses around everything. And look, nothing canceled. This whole set of parentheses is not the same as this set. Do not cancel these 10s. I know our brain wants us to cancel those 10s because they're the same on top and bottom. But it's an addition of 10, not a multiplication of 10. If there was a 10 out here being multiplied to everything, we could cancel them out. But this is addition. It's a term. It's a single term. The entire factor has to cancel. So everything, look, this entire set of parentheses does not match this entire set of parentheses. This polynomial does not match this polynomial, okay? So we cannot cancel it. So we're going to go directly to factoring the top and bottom. Now, let's look at this numerator. We can't take the 3 out, so I'm going to use my AC method to factor the numerator. I'm going to do it underneath. So 3 times 10, that gives me 30. I've got to add up to negative 11, so that's going to be negative 5 and negative 6. So I would get, now look, I'm going to kind of box this out. So 3x squared minus 5x, that would be one group, plus negative 6x plus 10, okay? So I split apart the numerator. And then I can factor what, an x out, and it leaves me with 3x minus 5. And then I can factor a minus 2 out, and it leaves me with 3x minus 5. So that leaves me with 3x minus 5 times x minus 2. So the numerator factors into 3x minus 5 and x minus 2. Okay? So that's just the AC method, right? That's why we went over the last chapter. I mean, this all builds on itself. The denominator, x squared minus 7x plus 10, we can do this one with the faster factoring because x squared is by itself. So I can put x and x here. Multiplies to get 10, adds to get negative 7. So it's going to be a minus 5 and a minus 2. And hey, check this out. these two cancel, right? The x minus 2's match. So they cancel. So we're left with 3x minus 5 on top over x minus 5 on bottom. Hey, hey, hey. Awesome. Sweet. Okay. Okay, great. I'm gonna give you a few examples and I want you to work these. I'm gonna give you a minute to work them. Okay. And it'll just kind of review what's going on and some stuff from the previous factoring section, right? I mean, this is a lot of review from chapter 5 on how to factor. So let me steal some here. I'm going to steal number 20 out of your homework. It says x squared minus 8x plus 16 over x minus 4. So try that one. And then let's do 24 because it's a little weirder. Flip it over here. 24, which says x squared minus y squared over y minus x. That's a good one. And then let's do number 30. Hold on. Yeah. No, we're gonna stop there. So let's do number. Oh, wish we had some more examples actually. I'm gonna make one up. So let's see here. Still want to do an example, but start working on those, and then we'll do one more just to review here. Yeah, this is actually one of the practice problems. We'll do P3, okay, one of the practice problems. 5x squared plus 13x plus 6 over 6x squared plus 7x minus 10. Okay, try those three. I'm going to give you a minute to try those. And then I'm going to email the class. I'm going to see if I can fix this issue we had with the last test. Okay, I think I fixed that. Okay, so let's start these now. Yeah, I just sent you guys an email about the test. Everything should be done. So let's look now at number 20. So we got to factor the top and bottom and then simplify completely. So I'm going to put parentheses around these. So the numerator factors into, and that's that nice factoring because x squared is by itself, there's no coefficient. So this would be what, minus 4 multiplies to give me positive 16, adds to give me a negative 8. Now we've only got 1 minus 4 in the denominator. So we're just going to cancel. You can choose either one, does not matter. And we're left with x minus 4. So that's going to be our solution. Now x minus 4 is in the numerator. It's not 1 over x minus 4, it's just x minus 4. Now the top, we've got difference of squares here. So I'm going to write this kind of on the side. So this would be x minus y, x plus y. Actually, that's just the definition of difference of squares. On the bottom, though, look, we've got y minus x. Now, if we had x minus y, we could cancel these out. So I'm going to do that trick where I factor out a negative, and it flips the x and the y around. So x minus y, right? Flips the x minus y around, and then now I can cancel the x minus y's. Okay. Now, this one's kind of weird, and that's why I chose it. This would leave you with x plus y on top and really a minus 1 on bottom. Now, look, we just don't leave minus 1s on bottom, just like we don't leave a positive 1 on bottom. Dividing by a negative 1 is the exact same as multiplying by a negative 1. It's the only number that does that other than positive 1, okay? So you can rewrite this, and your book's going to rewrite it as a negative 1 times x plus y, okay? They might even drop the 1 and just say this is negative x plus y. I've seen them do both, okay? But realize it's all the same. Actually, all three of these are the same. It's just a notation thing where we don't leave the negative in the denominator, okay? Now, looking at this last one, I'll tell you, the tough part's going to be factoring, right? The 5.5 stuff is what's going to be tough on both of these. These are both going to take either the AC method, get check method, however you like to factor. But I can't do the easy method like I did up here with this x squared minus x plus 8x plus 16 because we've got a 5 in front and a 6 in front. And nothing factors out, right? In the numerator or denominator. So I'm going to look at this first one, and I'm going to factor. So 5 times 6 gives me 30. 10 and 3 add up to 13. So this would become 5x squared plus 10x plus 3x plus 6, right? This is just the numerator factor. I can factor 5 out, so it leaves, hold on, I can factor 5x out, and it leaves me with x plus 2. And then I can factor 3 out, and it leaves me with x plus 2. These match, I can factor them out, so it leaves me with x plus 2 times 5x plus 3, right? So that's the top factor. So if I wanted to rewrite this, the numerator would be factored into x plus 2 times 5x plus 3. The denominator, though, so let's do this one over here. It was 6 times negative 10. That's negative 60. I've got to get 7. Oh, so it wouldn't be 10 times 6, right? The smaller number's got to be negative because it adds up to a positive. Let me get my phone out here, the calculator. So I'm going to do 60 times divided by 12, maybe. Oh, there it is. 12 times 5, right? And if you make the, so 12 times 5 is 60. Make the 5 negative, that'll add up to the 7. So 12 times negative 5 gives me negative 60, which is what I have to have. And then it adds up to a positive 7x. So this winds up being, if I want to factor it, I'm going to crack this open. So I get 6x squared minus 5x plus 12x minus 10. I can take an x out, so that leaves me with 7x minus 5. And then I can take what, 2 out? And it leaves me, with 6x minus 5. So it factors into 6x minus 5 times x plus 2. It's a lot of work, right? And that's just how it is, okay? To simplify these polynomials, these are going to be a little easier. But when you come to like a trinomial or a binomial or whatever on top and bottom, it's going to take a little more time. Or really factor trinomials, I should say, will take a little more time. So 6x minus 5 times x plus 2. And again, we've got some matching stuff on top and bottom. That can go away. Leaves me with 5x plus 3 on top and 6x minus 5 on bottom. And we are done. Okay? Any questions about those, you guys that are in class? Do you guys have any questions before we move on to the next topic?
None of this makes sense to me.
Well, it's going to take time and practice, right? This takes time and practice. And really, it takes knowing what we did in chapter 5. You've got to, like, if you look at this one, all we did was factor the numerator and denominator. This, all of this is section 5.5, okay? And then once we factored it, it's pretty easy. You just cancel out what's common, right? X plus 2 and X plus 2. And it leaves you with the simplified fraction, okay?
I'll try it out on the homework and see how well that goes.
Yeah, and I'm telling you, and what you're going to see is that it builds on itself. So the more you don't know, or the more you start learning at the beginning, it'll kind of start snowballing. And all of a sudden you're going to go, oh, why did I ever think that was hard? Okay, I'm stopping here, but I'm not stopping the lecture. Okay, so we're going to continue on with the next topic, but I'm going to make a second video for it. It's going to kind of separate right here. So give me just 1 second. You guys that are in the class, give me just